Hi, everyone. My name is McCauley Palmer, and today I'm presenting on exploring AI bias in organizational contexts and strategies to mitigate it with Dr. Mohammad Jarrahi, Chelsea Donahue, and Chris Wicher. To present this topic, I'll provide some context on how algorithmic bias emerged, its different sources, the interaction of those sources, and finally, strategies to mitigate those biases. Many current AI conversations are fixated on functional optimization for the purposes of driving profit, maximizing shareholder returns, and ultimately growing the business. This fixation is partly a product of Taylorism from 19th century US industrialism on the idea that the way to increase efficiency is to evaluate each step in a process and break down the production into specialized, repetitive tasks. There is the argument that automation frees workers from repetitive transactional tasks, providing the opportunity to upskill. The flexibility for workers to do higher level, potentially more impactful work is compelling, but it has risks if not all groups of workers benefit. Namely, it can neglect the reduction of human agency or the compounding disparate harmful impact on different groups. The second narrative is technological determinism, a reductionist theory on the societal impact of technology, suggesting that new technology directs and causes changes in society and culture. While this complex and divisive theory has been highly contested, there have been undeniable societal leaps because of technology and will continue to be so long as society has a need for progress and innovation. Technological determinism is regarded to lose credibility when the emerging technologies are adopted without the appropriate delicacy and testing on the premise that technology evolves as needed and informs human behavior, innately benefiting society. The argument that technology itself is not biased, that humans introduce bias, and that AI is biased, but it is better than humans, introduces a dichotomy of technology proponents and adversaries because of the bias embedded in this technology, its potential to shape our lives in unforeseen ways, and the societal progress that wouldn't be possible without it. And the controversy surrounding technological determinism leads me to this model for an AI bias typology my team has designed. I want to highlight that this is a work in progress. We're attempting to define the problem based on this simple typology, knowing that it may not capture everything. And the premise at this point is that the combination of these two frameworks, those being the sources of biases themselves and the interactions of those sources, allow us to create a comprehensive and somewhat interesting solution as we identified based on this triangular model. Next, I'm going to discuss the three sources with some important examples of how they manifest in organizations. As we all know, there are many different sources and forms of human biases, but these are some of the important examples of how human bias can present itself in algorithms used in organizations. Firstly, humans can unintentionally introduce confirmation bias in analyzing and synthesizing a system's outputs that can drive important organizational decision making. Secondly, the environment in which these systems are created can lead to biased outputs. A widely recognized issue in the field of AI is a lack of diversity in education on ethical matters. Furthermore, the designers often are isolated from the real-world context where the system would be used, thus not fully understanding the implications that design decisions could have on the community. Lastly, there is institutional or systemic bias, which emerges from outdated systems rooted or governed by practices that rely on or perpetuate bias and disparate impact. Similar to humans, data can be biased in many different ways, but these are some of the most notable manifestations into organizational contexts. There are three major ways that bias in data emerges: bias from how something was actually measured, bias from decisions to include or exclude specific variables in the data set, and bias from a sample not being representative of the broader population that will interact with the AI. While algorithms themselves are inherently objective, they can be built in a way that amplifies particular features of data that projects that particularism and therefore is a source of bias when applied to decision making. Here are two examples of how outputs can be skewed due to a system's intrinsic functioning that each strongly affect organization structures. First is bias in design, in that modeling of a system has limitations that restrain its accuracy. Second is when models are not appropriately designed or tested in an environment that is contextually similar enough to its practical or use or communal exposure. Now, most of the well-cited real-world examples of organizational algorithmic bias are not derived from just one of these sources, but are rather interdependent on the interaction of two, if not all three sources. So next, I'll provide some concrete examples of these interactions. First is the interaction of humans and data creating a problem of representation. An example of this is software used for determining the likelihood of recidivism in the criminal justice system. Algorithms such as the correctional offender management profiling for alternative sanctions have been heavily criticized for labeling African American individuals as much higher risk than other demographics. Human-produced data that is tainted with long-standing structural biases persists in models trained on this data. Second is the interaction of data and algorithms creating a problem of amplification. An example of this is an algorithm from a triage program that compared the survival rates of asthmatics with pneumonia and concluded that asthmatics with pneumonia were at lower risk for death than asthmatics that did not have pneumonia. Because of this, asthmatics with pneumonia were given lower priority in the healthcare system. The model's design failed to recognize the linkage between asthmatics and their previous immediate quality care. This connection was imperative to the prioritization of care and the reason why asthmatics with pneumonia have historically had higher survival rates. This is an issue of amplification because missing one minor variable data input amplified the potential effects of decision-making within an organization that involves human lives. Last is the interaction between algorithms and people creating a problem of contextualization. Most notably is the black boxing nature of deep learning algorithms and the lack of opacity and explainability of their internal functioning, making it very difficult to accurately contextualize the algorithm's use. An example of this are the proxies for race and gender that still exist in lending practices, notwithstanding the illegality of determining credit eligibility on those same factors. Credit scores, income, and data used by credit reporting bureaus, for example, have considerable linkages to race, gender, and other protected classes. Although race and gender aren't explicitly variables to these systems, proxies for these variables used in this context guide lending decisions which lead to disparate socioeconomic impact. AI deployment in the context of for-profit firms suffered from the two implicit narratives I discussed in the beginning of this presentation. Efficiency fixation focuses on minimizing costs and maximizing profits for shareholders with the use of AI, and that is motivated by a shareholder perspective. The other fixation problem is that of technological determinism, which implies that technology can and does drive good organizational changes. The two mitigation strategies I'll discuss refer to and address these two narratives. The pure shareholder perspective and efficiency fixation can be problematic in the deployment of AI because of the broader community of stakeholders that can be neglected. The stakeholder perspective allows us to maximize the benefits to the community that is impacted, such as employees and customers, which should be prioritized just as much as stakeholders are. Accounting for the well-being of all stakeholders capitalizes on their interdependency. If stakeholder theory posits that all stakeholders are equally important and behave interdependently, Taylorism would spark trade-offs between employee morale and share profits among other stakeholder relationships. Similarly, acting in the best interest of employees, customers, and the surrounding community would be in the best interest for the shareholders since they are interdependent. Bias in AI is a chicken-egg style problem in that it is difficult to decipher if these biases are rooted entirely in society or technology, but rather in a web of interactions between society and technology. If the problem is socio-technical, then the solution must also be socio-technical. This addresses the shortfall of technological determinism in AI deployment in that it considers the interdependency of society and technology that is necessary for organizations to accept and trust the technical subsystem into a social environment. A concrete example of this is the solution to utilize AI as an employee. By taking the steps to recruit, onboard, train, and promote technologies throughout an organization allows managers and system developers to use new mindsets that appreciate the unique characteristics of AI systems and how they can be actually contributing actors in optimizing a socio-technical environment. So, what's missing? Well, these two solutions are quite high level, serving as complementary approaches to the broader issue of algorithmic bias. More specialized, concrete socio-technical applications from a stakeholder perspective are needed to ethically optimize organizational AI deployment. Recognizing the intricacies of socio-technical interdependency allows humans to actively participate and shape the way technology is used in their organization. Human empathy is necessary in ethical deployment of AI and mitigating bias and the dehumanization from emerging technology. Conversely, technology has incredible potential to make the world a better place by providing objectivity to human decision making if designed appropriately. A socio-technical approach to gathering data, designing algorithms, and using them to benefit society has huge potential to upskill workers and make progress on worldly issues. Thank you on behalf of me and my team at the Keenan Institute for listening to this presentation, and we will gladly take questions.